Y'all notice? Fits the screen now. Nice. All right. So if you know how to do the graphs, you're basically working backwards. Thinking about, like when you looked at the actual equation of the function, there were certain things you were able to figure out from the denominator, from the numerator, from the matching factors. So let's work backwards and see if we can put that stuff back. And again, if you already know how to do this, wonderful. If you don't, here we go. And since you're not turning anything in until test day, I don't even feel bad if you weren't able to finish, because you can knock it out tonight or whatever. Okay, so what jumps out at you about a graph like this? Hole, maybe VAs, maybe places where it crosses the x-axis. I tend to look at holes first, because it's just an easy factor. I know that holes were canceled, and the actual factor came from not the y-coordinate, but just the x-coordinate, right? So you don't even have to worry about the y-coordinate. All I have to know is that if the x-coordinate of that hole is at -2, what factor was canceled? An x plus 2. So I'm going to go ahead and put those in there. I'm going to put an x plus 2 here and here, and that indicates where I had a hole. And if there was more than one hole, you're going to have more than one pair of factors. Okay, what else jumps out at you here? Okay, the horizontal asymptotes is important, but I always wait till the end on that. Okay, and because sometimes it's a good check. If I make a careless error, I can catch that error based on my horizontal or slant rules. You said vertical? Okay, I have a vertical at -3 and at +2. So let's look at the -3. What factor would I have had that gave me a -3 VA? An x plus 3, and where would that have been? In the denominator. So I'm going to put an x plus 3 down here. And then for the 2, I'm going to have an x minus 2 down here. And then that right there, that represents my VAs. And then what else would have shown up in this graph? X-intercepts. X-intercepts are there and there. Are there bounces? So there's no double roots. Are there any cubic roots where it looks like it flattens out for one instant and then goes down? No, these just go straight through, straight through. So they're single roots. So the factors here would not be squared or cubed or anything. And that one crosses at -4. So that would be an x plus 4. And that crosses at -1. So that would be an x plus 1. And those represent my x-intercepts. Now, remember that the y-intercept was just a product of me plugging in a 0 for x. So if you want to check that at the end and make sure, great. But it doesn't actually show up as a factor, does it? The only things that show up as factors were holes, VAs, and x-intercepts. So I do have to think through the horizontal or the slant, though. So here's what I'm going to do. If I were to have multiplied this out, what would my lead term have been right here? If I multiplied that times that times that. A 1x cubed, and then a bunch of other junk, right? Does that make sense to everybody? Because if I FOIL these, I'm going to have an x squared, and then if I multiply x squared by an x, I'm going to have an x cubed. And then same thing with these, because they're all 1x's. When I FOIL, multiply all that junk together, I'm going to get this. Now, if I had ended up with that, what would my horizontal asymptote have been? What did we do when the powers are the same? We put 1 over 1. So I would have had a horizontal of y equals 1. You don't have a horizontal of y equals 1, do you? You have a horizontal of y equals 2. Well, what does that mean then? I need that to be a 2x cubed. So you could either put the 2 and multiply it in each one of these, but I don't bother. I just say, let's just put a 2 out front. That would make this end up being a 2x cubed, and then that would make this have a horizontal 2. And that's it. And if you're thinking to yourself, well, how do I know that hole is right there? Well, you could technically take a -2 and plug it in there, 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 and there. You don't want to plug it in there because you get 0 over 0. But look, if I did, plug a -2 in for x, and that gives me a +2, a -1. I don't do this, by the way. A +1 and a -4. The negatives cancel, the 4 cancels, and I get +1. There it is. And you could plug in 0 for x and see what the y is. If I plug in 0 for x, I get 2. Those cancel, but I'll leave them in there. 2, 3, and a -2. And I get 4 over -3, -4/3. And that looks like about -4/3. So you don't even have to check the whole, you don't have to check the y-intercept. You can see that if you represent the whole, the x-intercepts and the VAs, and then account for the horizontal, or you'll see in a second the slant, everything else works out. So it really boils down your thinking to just those 4 categories. So if you account for all 4 of those, everything else will work out nicely. All right? And again, if it doesn't, well, maybe not again, if it doesn't have a horizontal, it would have a slant. And I'll show you accounting for the slant is relatively simple. It's the same kind of thing. The only thing you have to be careful about, and I'll show you one of these in a second. Everybody with me? Got some people zoning out. The only thing you got to be careful about is if it bounces, remember that will square one of these roots. If it has one of those cubic things where it looks like it's flattening out but then it reverses, that's going to cube one of these x-intercepts. And do you remember the volcano graph? Remember how the volcano graph went like this on the asymptote? But it was squared on the bottom, wasn't it? And you'll notice here, these don't go in the same direction, do they? But if you ever see them go in the same direction, that means that asymptote, that vertical asymptote's factor, would be squared. That's another thing you have to look for. And those are the things that kind of get you nickel and dimed. If you forget to square it, ... If you forget to account for the double root, ... If you forget to account for the horizontal asymptote, ... And you can really lose points on this, but if you have all those things in mind, it's pretty easy to, well, I say relatively easy to do these. So let's look at a couple more. Again, if you already know how to do these and you did them all correctly, awesome. How about, do I have any nasty ones? We'll try the, well, that's a horizontal. Okay, how about this one? Oh yeah, this has got everything going on. Look at number 9. So if you can do number 9, you can do anything I'm going to ask of you. I might give you one a little uglier than this, but not uglier in mentality. Because this has got every possible little way I could mess with you. Okay, so as you're going through there, what's the first thing that pops in your head? The whole shows up at +2. So my factors are, all right, so I have accounted for the whole. There's only one of them, so I'm good with that. Now what? VA at -4. Now, is there a volcano going along that? I hate that I'm actually saying volcano and being filmed. If it's not going in the same direction, it can't be squared, so I know that's a single root. There's also a what? A VA at 3. So x -3, but what do you see on this thing?
A volcano.
Yes, or a whirlpool, who knows what. But it's going down along the same direction on both sides. So what does that mean about that factor? It's going to be squared. So this represents my VAs. Okay? What else we got going on? Root at -3 or 0 or x-intercept? No bounce though. Root at 1, so x -1, bounced, squared. And then root at 4, so that represents all of my x-intercepts. Now you're looking at this and you see a slant. When do slants happen? When the power is 1 bigger on the top than the bottom. So this is a great way to check your work. If I look at this and I go, all right, I have 1x, 2x, 3, 4, because it's squared, 5. This would have been an x to the 5th. and on the bottom I have 1, 2, 3, 4, that would have been an x to the fourth. So because it's one higher on the top, that means if I were to have done the division, I would have gotten something x. And that is a slanted line. Yeah.
Is it only if it's one higher?
Yes, because if it were two higher, then if that was a 6, when I divide an x to the fourth and the x to the sixth, I would get an x squared. And you would have a parabolic asymptote. You're not going to see those on these, and I'm not going to require that of you. But it's possible that you could have that, but if it's slanted, it'll always be 1 power higher. And this is how you catch your mistakes. Because if I had forgotten to put that squared there because of the volcano, then I would have had this, right? When I checked it, and I would have gone, wait a minute, that wouldn't have been slanted. This is slanted. What did I forget? Oh yeah, the volcano. Or if you forgot this squared right here, you would have ended up with x to the fourth, right? So if you forgot the bounce on that intercept right there, you would have gone, wait a minute, that should be a horizontal at y equals 1. But it's not. What did I forget? Oh yeah, I forgot the bounce there. So these are the kind of checks that will help you. Now, here's the thing. Once you get to here though and start looking at it, what kind of slant asymptote would I have if I divided an x to the fourth into an x to the fifth? When I did the first division, what would you have gotten? 1x, which means you would have ended up with a line that looked like that, right? Well, that's a slope of 1. Slope of 1. Do you have a slope of 1? And by the way, sometimes it's hard to tell the slope. Like it might be hard to look from here to here and see slope. So just find out 2 places where you're very confident that it crosses. Like, looks like it crosses there, looks like it crosses there. So based on that, what do you see? 2/3. So you need for it to be a 2/3. Well, what should this number out front be right there for that to end up to be a 2/3? 2/3. Or this because if I divide that into that, I get 2/3. Well, look, basically do it exactly the same way you did a horizontal. You don't have to overly think through this. Just look up here and say, all right, I want a 3 on the bottom and a 2 on the top, so 2/3. So you look at the horizontal and you see a 2, put a 2. If you look a slant and you see a 2/3, put a 2/3. And you can put the 2/3 on the top or the 2 on the top and the 3 on the bottom. Either one. I tend to do this. Are y'all seeing that? Honestly, that's probably as ugly as they would get. I'll do one more here. Look at number 8. All right, so number 8. What do we got? Hole at 4. Then VA at -3. Different directions. VA at +2. So x minus 2, but look, same direction. Crosses at -5. Crosses at -1. Crosses at 3. Now, a lot of people every year forget that squared. But this is what I'm saying. If you're thinking about all the math, you'll catch that mistake. Because this would have been an x to the fourth over an x cubed if you forgot the squared. What should an x to the fourth over an x cubed give me? A slant, and there's not a slant. So where's my other x in the bottom? So these kind of things, if you really understand what you're doing, you can catch some of those mistakes. And I go back and I go, oh, look at that. There's the volcano happening right there. So right there, that should have been squared. Now I have an x to the fourth over an x to the fourth. But an x to the fourth over an x to the fourth would have given me a y equals 1. And is this a y equals 1? What's it look like to you? 2.5, which is 5/2. I mean, you could put a 2.5 if you wanted to up there. It's right. 5/2 to me looks a little prettier. You tracking with me? All right. Good times. All right, normally at this point, this is what I do. I pair you up or group you up, and I give you some more problems to do, but I really throw this at you. Analyzing rational functions, part 3. And you can jump to this if you want. But because you're not in groups and you can't collaborate, I'm going to do one of these collaborative projects with you. Now, what would I have loved for this thing to look like? Like, what do you need in order to be able to start doing stuff with this? Get it all factored. Volunteers to factor a 4-term polynomial? Okay, I don't know rules of factoring there. But I do know how to find what? And we just did it with polynomials. Use synthetic division and possible rational roots to shrink this puppy down. And once I find all the roots, what can I do with these roots? Turn them into factors in the numerator, right? And then right here, that's probably more factorable. And by the way, I know when you look at 36 and 3, you're going to go, man, you're a jerk. That's a zillion possible rational roots. And it is, but what do you see in common here? And a 2. If you factor out the 3 and the 2, it's probably going to help your possible rational roots shrink down significantly, and I bet you find them pretty quickly. So the first goal here would be get this thing factored. All right, so let's check that out. If I wanted to try to get that factored, I'm going to pull a 3 out, and that gives me x to the 4th minus 2x cubed minus 7x squared plus 8x plus 12. And pulling a 2 out of this, x to the 4th minus 10x squared plus 9. So I'm not going to look at that original thing anymore. Right? Now, what do you want to start? If you want to start factoring this top part, what would you use to start factoring it? Or to start seeing which roots actually worked? Factors of the 12 over factors of the 1, now that the 3 is out. Oh, so here are your possible rational roots. 1, 2, 3, 4, 6, 12, all over the 1. Now, I know that's a lot, but I bet you find them pretty quickly. So maybe start with a 1. Does Descartes' rule help you with this at all? Plus, minus, minus, plus, plus? Probably not. It's not one of those special patterns. Do you remember the special patterns? If they're all, what? All the positive are all the same, or if they alternate, then that's probably going to give us some good information and knock out some of our options. But I don't see that. So if I check positive 1 in there into 1, remember what the number, the top 2 mistakes are in synthetic division? Forgetting a 0 when necessary, and what? Copying the problem down wrong. So really be careful about those 2 things. So let's check this out. I'm going to just kind of race through this. 1, negative 1, negative 8, 0, 0, 12. Let me double check my math. Okay, so definitely not working on that. So I go back and I try negative 1. Back in the original. And for what it's worth, I don't erase, because if I go through all of them and can't find them, I go back and I at least see where my careless errors were. Try negative 1. 1. If you see a mistake, let me know. Feeling good about it? Yes. Okay, I got my first root, and I've shrunk it down. So then I go to maybe 2. I'm going to use the shrunken down portion. So you got a bunch of stuff going on here. If you're thinking to yourself, are you going to do this to us on a test? The answer is no, because if you get stuck on the very first part, the whole problem's junk. But you will have to know this. This is part of the test you'll do. So you'll do a problem like this on the test, and then, but I'm not going to start you with something like this. If I do, it'll already be factored. And then, I normally told you on these last two to use a quadratic formula because it won't factor. It's going to factor on this one just because I want it to give you nice clean roots. So check it out. If you put x's in there, it factors into x minus 3, x plus 2. So 3 and negative 2. So those are my 4 roots. And if those are my 4 roots and none of them's a double root, what could I do with all 4 of these? I could change them back into factors, and that would be my, or just use them as x-intercepts, right? But I want to make sure that these don't cancel. There's a chance that these cancel with something in the denominator, which would make them not x-intercepts, but rather wholes. So I'm going to go ahead and say, all right, here are my factors up here. I have that 3, which is just a whole number. And then I've got x plus 1, x minus 2. And then also x minus 3, x plus 2. All right. Good job, guys. Now what? That looks a little more factorable, right? Doesn't look as daunting as the rest of them. I know how to do quadratics. Quadratics are things that are in quadratic form. So let's check this out. This part right here, let's just try it. X to the 4th, x squared. 9, but I need negative 10 in the middle. How about negative 9, negative 1? So that works, and then that factors further. So x plus 3, x minus 3, x plus 1, x minus 1. Great. So x plus 3, x minus 3, x plus 1, x minus 1, and remember, don't forget the 2 that was out front. So again, I wouldn't make all of this one problem for you, because if you make one little error, you can't do anything else with it. So I would probably start you with something like this. So what can you do? If you saw this first. There's a hole at negative 1. So I have a hole at x equal negative 1. Any other one? There. Also at positive 3. How do I find the y values that go with those holes? Okay, so I'm going to do that over here. If I plug a negative 1 in the numerator and the denominator, I get 3, negative 3, and 1 on the top. And I get 2, positive 2, and negative 2 on the bottom. All right? I would advise you on your test to show me this work when you're doing it. Because if all you do is write the answer and it's wrong, you get dotted or whatever. But if I see that, I might go, oh, I forgot a negative sign minus a half a point. You might save yourself a little trouble. And it's easier to kind of do that anyway. So the 2 negatives cancel, and I get 9 over 8. If I make a careless error, tell me quickly. And then if I plug the 3 in, I get 3 times 1 times 5 over 2 times 6 times 2. And the 3 does cancel with that and leave me 5/8. So I got 9/8 for the first one, 5/8 for the second one. And I'm going to write that actually over here because I'm about to move up so I can see this. So my holes are at negative 1, 9/8, and at positive 3, 5/8. And where are my x-intercepts? They're not all 4 of those factors. There's only 2 left, right? So my x-intercepts are what? So my x-intercepts are positive 2 and negative 2. So 2, 0, negative 2, 0. How do I find the y-intercept? Plug in 0 for x. So my y-intercept, if I plug in 0 for x, I like going back to the original problem if I can. Check it out. I mean, look how nice the original problem is. If I plug in 0 for x, everything goes away except these constants. So what's the y value? 36 over 18? 2. And what are my VAs? What's left to be a VA? X equals -3, X equal 1. And what is your HA or your slant? Which one do I have here? Horizontal, because the powers are the same. So Y equals 3/2. Is there anything else I need to know here? I got my holes. I have my VA. I've got the horizontal, the slant. I've got that. I've got the x-intercepts, the y-intercepts. I should be able to graph this thing. So you would come in here and just start marking everything off. VA at -3. VA at 1. Horizontal at 1.5. X-intercept at 2, 0. X-intercept at -2, 0. Y-intercept at 0, 2. Hole at -1 up 9/8, which is just barely over 1. And a hole at 3 5/8, which is about a half, a little bit bigger than a half. Now another thing I do on a test, I realize that sometimes in the process of doing all this, you accidentally get the sign wrong there. Or maybe you write +3 instead of -3. And if you put a vertical asymptote at +3 instead of -3, it confuses all the other information. And it makes your graph a mess. So oftentimes, I'll just give you a picture with some stuff on it. Like this. And I'll tell you things like, A, the factors that you got the VAs from were not squared. So you go, oh, well, that means no volcano. And I'll say the factors that you got your x-intercepts were not squared or cubed or whatever. And you'll go, oh, that means no bounces, right? And then I'll say, all right, with this information, sketch the best graph you could possibly graph. Now, my advice to you is this. Dealing with that kind of information is kind of like, when you go and you take a multiple choice test, and you really don't know the material that well, but you're smarter than maybe the person who made the test up, and you're like, I don't know the answer to this, but I know it ain't A, and I know it ain't B, and I know it ain't D or E, so it must be C, even though I don't even know what C means, and you end up getting a pretty good grade just by default. That's the way you need to think with this. So if I'm wondering to myself, well, what's the graph doing? It's really more about what the graph can't do. Like, for example, why can the graph not do this? Based on the directions I just gave you. If it bounced right here, then that x -2 factor right there would be squared. But it's not squared, right? So that's a mistake that you made that you could have caught if you really had everything down. Okay? Why can't it do this? Well, for one, these two x-intercepts are not like the obvious x-intercepts, and there's some super secret x-intercepts that are out there. This is it. The only places this thing can cross the x-axis are right here, because that's the only way for y to be equal to 0, is if those are 0. So it couldn't cross there if it wanted to. Okay? Why is this wrong? Do what? Throw it out there. The x-axis is not an asymptote. It might be, but it's not here. What does your graph have to do as it heads to infinity? Follow the slant or the horizontal. And this one's got a horizontal. So it has to, by default, go through those 2 points. It can't bounce. It has to go either down or up the asymptote. It can't go up because that would mean a bounce. And it has to follow this one out. Why can't it do this? Why can't it go through this one and then follow it up. I see all of these things on tests. I just gave it another x-intercept, and it doesn't have any. So guys, really, again, it's kind of like taking a multiple choice test. It's not knowing what it does, it's knowing what it doesn't do that will guide you in going, all right, must do that. All right, what about in the middle? What does it have to do? All right, tell me why this doesn't work. Doesn't have a double root at x plus 2. It's not bouncing there. So that's impossible. I normally blow to dry it. That is not an option. Why doesn't give me 2 reasons why that doesn't work. There's not another x-intercept, and there's not a volcano, is there? So there's 2 reasons that's got to mess up. Why doesn't this work? That's a trick question. It does work. It probably actually goes more smoothly through there. Because if it doesn't go smoothly, and it has a funny wiggle in it, what do those wiggles mean? Imaginary numbers, and you don't see any imaginary roots up there in the numerator, do you? Right? But if there was a wiggle, like if it came down here and went wiggle and then through there, so it's probably nice and smooth through there. All right? What about this side? I always get people that go, oh, there's nothing over there, there's no points. Okay, there's no points that are x-intercepts, and there are no holes there. But who says there aren't points? Isn't this a function? Is there anything wrong with me plugging -4 in there for x? Or -5 in there for x? I'm going to get some answer, right? The only things I'm not allowed to plug in are -3, +3, -1, and +1. So there's got to be something there. And by the way, what is this horizontal asymptote doing again? It is guiding the graph to the right and to the left. So you know this graph is following this. So let's think backwards. If it follows it all the way out to here, if it follows it all the way out to there, think about it. As I'm coming in, I'm either on the top or the bottom. So let's think. If I was on the top, what most likely would I probably do? Rise up. And if I was on the bottom, what most likely would I do? Go down. What can I not do? Why not? The volcano would happen, and that's not a squared factor, but what else? I would have to cross and get an x-intercept. So anyway, it can't be A, can't be B, must be C, or whatever. So you know that this thing must cross somewhere, must do something like this. Now, if you're really wondering, well, how do I know whether it's there, or there, or there? Well, that would probably require you plotting another point. Like saying, all right, let me just plug in a -5 in here, plug in a -5, which I'm not going to do, but if I did, I bet I get a value that will help me sketch this thing better. And a lot of times I do ask you to do that. You all with me on this? So anyway, that's the gist of what we're doing today, is just kind of ironing out any wrinkles that you have and just making sure that you're good on all this stuff. But if you can do this thing, that is, or the next one, you're not going to see anything that terrible. Terrible. Who says that? My wife says that all the time, and just yesterday, I was like, I love that you quote Barkley. She goes, what are you talking about? I was like, terrible. That's Charles Barkley. She didn't even know. She says that all the time. Like, that's terrible. Anyway. So right here, these are not some things that are going to show up on your test as one problem. But you very well may get a problem like this, and I say, solve, find the roots. You may get a problem like this, and I say, factor over the rational numbers. All that stuff is a part of this. I had just given you these 2 problems in years past because you would get in groups and you'd put your brains together, and people were like, hey, you do the synthetic division, I'll do this, blah, 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 and you could get through the problems okay. We just don't have a lecture of that this year. All right? At least not yet. Not yet. What's that from? Don't know that.
Sounds like tornado.
Guy's talking to another guy who's passed away in his brain. He's like, I will see you soon. No, yet. Nobody? Gladiator? Y'all watch Gladiator? Y'all have never seen Gladiator? Really?
I think it's time for a film.
You know how great it is to have not seen one of the greatest films ever? Y'all, nobody in here seen Gladiator.
Didn't we watch it in 8th grade? Like,
Maximus Aurelius?
Edited version.
Russell Crowe?
We watched like half of it.
Yeah.
Y'all seen Braveheart?
Yes.
You seen Shawshank Redemption?
Yeah.
I watched it because of
The
I
great
saw it on
stuff.
Netflix and I was like, I've seen that Mr. Hurry.
So good. Okay,
You could use that overtime bonus.
before Christmas, with your parents' approval, of course, unless you're 17, you gotta watch Braveheart and Gladiator. So good. Two of the greatest films of history. And they're period pieces, so it's not like, what is that guy wearing? It's not like, it's just, old-timey stuff, but it's so good. It's not like, I don't know, maybe you do see it like that. I'm getting old. So good, though. Y'all with me? Y'all have any questions on any of this at this point? Anything with rational functions? Yeah.
Horizontal asymptotes, what's the rule? Like, it can pass it, like it can cross it?
Oh, great question. And I haven't mentioned that yet. A lot of people get in their head that you can't cross asymptotes. That's not true. Okay, there are some graphs that will cross an asymptote an infinite number of times. Weird looking graphs like sine of 1 over x or whatever. The rule is you can't cross a vertical, but you can actually cross slants lots. The idea of an asymptote is this, and make sure you hear this. Asymptotes, not vertical asymptotes, but asymptotes, their property is, if it's slanted, by the time you get to infinity, it better be hugging that line. Like that, hugging that line. Verticals, as you approach it, you better be hugging that line. And there are other options for verticals. Horizontals, by the time you get to infinity, you better be hugging that line. But verticals are the only ones you can't cross. Like you can't cross that because it's undefined, because it's from the denominator. These other ones don't have, they're not defined that way. So very often, you might do something like this. Right? You might not be able to cross the vertical, but you might cross that horizontal. In fact, I've seen graphs like this. They might even cross the horizontal like this and then come back. So you can cross horizontals. Don't get to a graph and go, wait a minute, I can't complete this, I can't cross. Horizontals, slants, you are allowed to cross them. You will see this sometimes. They'll come in like this and then cross them like that. They may cross again like that, and then they may follow their way up. You just can never cross a vertical asymptote. Are y'all hearing that? Great point, because I have not said that. And I have people all the time that get to the test and think, well, I was told you can't cross asymptotes. Well, you might have been, not by me. But you might have been, but what my guess is, probably Miss Tyree says, oh, you can't cross vertical asymptotes, but those may be the only ones you were dealing with, or maybe Helmer's. He probably said you can't cross verticals, but because those may be the only ones you were dealing with, that's what's stuck in your head. Oh, asymptotes can't cross them. Vertical asymptotes can't cross them. The other ones, sure. You probably don't much unless you're kind of in the middle. This is where they tend to cross. If they're going to cross, it's somewhere in the middle. But remember, the graph goes forever. So once it's heading towards forever right or forever left, they probably don't cross much anymore. They probably are just coming in from the top or coming in from the bottom, like that. But right here in the interior core, the guts of it, yeah, sometimes they cross. Great point. Anybody else on anything? Feeling pretty good? We're here for a dominating performance on Monday and Tuesday. Tuesday for y'all. All right. You in your graph Tuesday? You test Tuesday? Yeah. Pretty sure that's it. Yeah. So if you can finish up parts 1, 2, and 3, you're in great shape. If you have any questions on those, please bring them to me and let me get you straightened out. You can email them to me. If it's a quick answer, I can just respond back to you. Maybe make a quick video and send you a link. That kind of stuff works for me. Or if I can just go, you know what, we're going to review this, I can cover it on the review day. And I'll just add your, like right here, I've got a list of problems to talk about in AP Cal today from somebody who just sent it in. And it's our review day. So that works great as well. All right? All right. That's all I got. You have 5 to 6 minutes of freedom.